It has been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe.
There was estimated that there were maybe a planet around every 100 stars. Well, now we think, in order of magnitude, there's 10 planets around every star.
Today, we're going on an exciting journey to the smallest planet in our solar system, Mercury. Now, I know what you're thinking. Why Mercury? After all, it's tiny, rocky, and it's sitting right there next to the sun. But believe me, Mercury has a lot of secrets that have left scientists scratching their heads for years. From its extreme temperatures to its bizarre magnetic field, there's more to this planet than meets the eye. So let's buckle up and take a deep dive into the mysteries of Mercury. Mercury, the smallest planet in our solar system. So what do we know about Mercury? For starters, it's the smallest planet in the solar system, which is a title it holds quite distinctly. In fact, Mercury is actually smaller than some of the moons that orbit other planets, which is pretty wild when you think about it. Our own moon is even bigger than Mercury. But don't let its small size fool you. Mercury has an incredibly dense core that contributes to its high surface gravity. The planet is also known for its extreme temperature fluctuations, with daytime temperatures soaring up to 800 degrees Fahrenheit and plummeting to minus 330 degrees Fahrenheit at night. This makes Mercury a place of stark contrast. Additionally, its lack of atmosphere means that it's constantly bombarded by solar radiation and micrometeorites, adding to its rugged, cratered surface. Mercury truly packs some fascinating mysteries, making it a compelling subject for further exploration and study. Mercury is one of the 4 terrestrial planets in the solar system, meaning it's composed primarily of rock and metal, much like Earth, Venus, and Mars. These planets all have a solid surface you could theoretically stand on, though with Mercury, you'd have to ignore the fact that you'd either be roasted by the sun's intense heat on the day side or frozen solid on the night side. Mercury's surface is covered in craters, much like our moon, bearing the scars of countless collisions with asteroids and comets over the past 4.5 billion years. These impacts have shaped its rugged landscape, creating deep basins and towering cliffs. Interestingly, Mercury lacks the thick atmosphere that Earth has, so it doesn't experience the same erosion processes. What you see on the surface has remained relatively unchanged for billions of years, providing a window into the planet's long and tumultuous history, the enormous core. One of the most interesting things about Mercury is its massive iron core, which makes up about 85% of the planet's radius. To put that in perspective, Earth's core only accounts for about half of its radius. This means Mercury is almost like an iron ball wrapped in a thin, rocky shell. It's a fascinating feature that sets it apart from the other terrestrial planets. But why does Mercury have such a disproportionately large core? What could have caused this? Scientists believe that in the early days of the solar system, Mercury may have been much larger, with a thicker crust. However, a huge collision with another celestial body might have stripped away much of its outer layers, leaving behind the dense, metal-rich core we see today. This giant iron core also gives Mercury a surprisingly strong magnetic field, despite its small size, adding to the list of mysteries surrounding the planet. Well, scientists have been trying to crack that mystery for quite some time, and there are a few compelling theories. One popular theory is that Mercury was once a much larger planet, but during its early history, it was hit by a massive asteroid or comet. This colossal impact could have stripped away much of Mercury's outer layers, leaving behind the dense iron core that dominates the planet today. Essentially, what we're left with is the planetary skeleton of what was once a bigger body. Another interesting theory suggests that when Mercury formed billions of years ago, its proximity to the sun played a crucial role in shaping its composition. The sun's intense gravity could have pulled away the lighter elements, like silicates, from the young planet's surface, leaving behind mostly heavier metals like iron. This would explain why Mercury has such a massive core compared to its overall size. Both of these theories offer insights into Mercury's unusual structure, but there's still much to uncover. Ongoing space missions and research continue to help scientists piece together the planet's mysterious past, making Mercury an intriguing subject of study in our solar system. Whatever the reason, Mercury's core is massive, and that has a lot of interesting consequences. For one thing, it means that Mercury has a lot of gravity for such a small planet. If you were standing on Mercury, you'd feel about 38% of Earth's gravity, even though Mercury is much smaller. This is because gravity depends on mass, not just size, and Mercury's dense core gives it more mass than you might expect from its size. A comparison with other planets. Let's take a moment to compare Mercury to the other planets in our solar system. Earth, the planet we call home, is about 4 times the diameter of Mercury, making it significantly larger. Venus, which is often called Earth's sister planet due to its similar size and composition, is a little smaller than Earth, but still far bigger than Mercury. Even though Venus is our closest planetary neighbor, its massive atmosphere and scorching heat make it quite different from Mercury's barren, cratered surface. Then we have Mars, the red planet, which is about half the size of Earth. Despite being smaller, Mars is still larger than Mercury. Mars also has a thin atmosphere and evidence of water, adding to its intrigue. Compared to these planets, Mercury stands out as the tiniest in the inner solar system, but its extreme temperatures and massive core make it anything but ordinary. Now, when you look at the gas giants like Jupiter and Saturn, they're in a completely different league. Jupiter, the behemoth of our solar system, is so massive that you could fit over 1,300 Earths inside it. Saturn, while slightly smaller and less dense than Jupiter, is still incredibly large, with its iconic rings making it even more impressive. Compared to these giants, Mercury seems like a tiny pebble just floating in the vastness of space. But size isn't everything, and Mercury definitely proves that. Despite being the smallest planet, it packs a punch with its dense core, extreme temperatures, and magnetic field. Plus, its unique history, whether it's the result of a giant impact or the sun's gravitational pull, makes it a fascinating object of study. So while Mercury may be dwarfed by the likes of Jupiter and Saturn, it has plenty of intriguing features and surprises up its sleeve. The early days of exploring Mercury. Before we sent spacecraft to explore the planets, Mercury was kind of a mystery. You see, Mercury is hard to observe from Earth because it's so close to the sun. The sun's glare makes it difficult to get a good look at Mercury with telescopes. It only appears briefly in the sky just before sunrise or just after sunset, and even then, it's usually low on the horizon. Mariner 10. Our first look at Mercury. That all changed in 1973 when NASA launched the Mariner 10 spacecraft. This was the first time we sent something to visit Mercury up close. Mariner 10 didn't actually orbit Mercury, but it did perform 3 flybys, each time getting closer to the planet and sending back valuable data and images. The images Mariner 10 sent back were our first real glimpse of Mercury's surface. And guess what? It looks surprisingly similar to our moon. Mercury's surface was peppered with craters of all shapes and sizes, a testament to the countless impacts it has endured over billions of years. Some of these craters were absolutely enormous, suggesting that the planet was struck by massive asteroids or comets during its early formation. The largest crater that Mariner 10 uncovered was the Caloris Basin, a colossal impact crater about 1,550 kilometers, 960 miles, across. To put that in perspective, that's nearly half the width of the United States. The sheer size of this basin gives us an idea of just how violent Mercury's past must have been. The force of the impact that created Caloris was so intense that it caused weird terrain on the opposite side of the planet, where the shock waves traveled through Mercury's core. These craters, along with Mercury's rugged surface, reveal a history shaped by ancient cosmic collisions, making it a planet filled with both scars and stories. The formation of the Caloris Basin must have been a catastrophic event. Whatever hit Mercury to create that crater was likely a huge asteroid or comet. The impact would have sent shock waves through the entire planet, creating wrinkles and cracks on the surface, some of which stretch for hundreds of kilometers. These wrinkles are called lobate scarps, and they're unique to Mercury. But Mariner 10's discoveries didn't stop there. One of the most surprising revelations was that Mercury has a magnetic field. This was completely unexpected because small planets like Mercury aren't typically thought to have magnetic fields. The reason is that magnetic fields are generated by the movement of molten metal in a planet's core, a process known as a dynamo. Scientists had assumed that because Mercury is so small, its core would have cooled and solidified long ago, making a magnetic field impossible. But Mariner 10 proved them wrong. Somehow, Mercury's core remains partially molten, allowing it to generate a weak but detectable magnetic field. This discovery has led scientists to rethink their understanding of how planetary cores cool and evolve, especially in small planets. Mercury's magnetic field adds another layer of intrigue to this tiny planet, showing once again that it's full of surprises. Messenger, taking things to the next level. Fast forward about 30 years, and we get another mission to Mercury. Messenger. This spacecraft was designed to do something Mariner 10 couldn't: enter into orbit around Mercury and study it in far greater detail. Messenger launched in 2004, embarking on a 7-year journey that included multiple flybys of Earth, Venus, and Mercury itself, before finally reaching its destination in 2011. Once in orbit, Messenger provided us with a wealth of new data, revealing more about Mercury's surface, magnetic field, and its mysterious core, helping us understand this small yet fascinating planet like never before. Messenger orbited Mercury for 4 years, delivering a treasure trove of data and images that transformed our understanding of the planet. One of its most impressive achievements was mapping Mercury's entire surface, giving us a complete and detailed picture for the very first time. Over the course of its mission, Messenger sent back more than 200,000 images, an incredible number that provided scientists with invaluable insights into Mercury's geology, craters, and mysterious features. Thanks to Messenger, we now have a far clearer understanding of this small, rocky world and the complex processes that shaped it over billions of years. One of the significant discoveries Messenger made was that Mercury's surface wasn't just a barren landscape covered in craters. There were also clear signs of volcanic activity. Scientists found enormous lava plains scattered across the surface, indicating that ancient volcanoes once erupted and spilled lava that flowed across the land. This volcanic activity covered older craters and created smooth, expansive surfaces, hinting at a much more dynamic past. This finding was a big deal because it suggested that Mercury wasn't always the dead rocky world we see today. At one point in its history, the planet had active volcanoes, challenging our understanding of its geological evolution. The presence of these lava flows indicates that Mercury experienced significant geological activity long after it formed, providing new insights into its history and the processes that shaped it over billions of years. This revelation has opened up exciting avenues for future research about Mercury's complex and dynamic nature. But that's not all. Messenger also discovered something even more surprising: water ice. Now, I know what you're thinking. How can there be ice on a planet so close to the sun? That's a great question. During the day, temperatures on Mercury's surface can soar to an astonishing 430 degrees Celsius, hot enough to melt lead. However, at night, the temperature can plunge to a frigid minus 180 degrees Celsius. This massive temperature swing, the largest of any planet in the solar system, creates conditions in certain permanently shadowed craters that allow water ice to exist. These regions remain hidden from the sun's intense heat, preserving the ice and adding another fascinating layer to Mercury's complex environment. The discovery of water ice has important implications for understanding not only Mercury's history, but also the potential for resources in future space exploration. So where does the ice come from? Well, it turns out that there are places on Mercury's surface that never see sunlight, specifically in craters near the poles. These craters are in permanent shadow, which means they stay incredibly cold all the time. Even though other parts of the planet are baking in the sun, Messenger's instruments detected bright patches in these craters, which scientists believe are deposits of water ice. This discovery was a huge surprise, and it shows how even the most extreme planets can still hold unexpected secrets. A year shorter than a day. Now here's one of the weirdest things about Mercury: its day-night cycle. On Earth, we're accustomed to a day lasting 24 hours in a year, taking 365 days. But on Mercury, things work very differently. In fact, 1 year on Mercury, the time it takes to orbit the sun, is only about 88 Earth days, making it much shorter than a single day on the planet. A full rotation on Mercury takes about 59 Earth days. This means that as Mercury spins on its axis, it takes nearly 2 Mercury days to complete one orbit around the sun. Let's break that down further, as this unique rotation and revolution pattern results in some extraordinary temperature variations and an unusual experience of day and night on this tiny planet. Mercury takes just 88 Earth days to complete one orbit around the sun, making a single year on Mercury a mere 88 days long. But here's the crazy part. It takes Mercury 176 Earth days to rotate once on its axis. This means that a single day on Mercury lasts twice as long as a year. If you were standing on the surface of Mercury, you'd experience a sunrise that would be breathtaking. However, you'd have to wait a staggering 88 days for the sun to set again. And once it does set, you'd need to wait another 88 days to witness the sunrise once more. This unique day-night cycle leads to some extraordinary temperature variations. During the day, the surface can heat up to around 430 degrees Celsius, 800 degrees Fahrenheit, while at night it can plummet to a chilling minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Imagine the extremes. This peculiar relationship between its rotation and orbit creates a Mercury day that is unlike anything we experience on Earth, showcasing the planet's fascinating and complex nature. It's a wild and captivating aspect of this tiny world that continues to intrigue scientists and space enthusiasts alike. This slow rotation is caused by a phenomenon called tidal locking, which is the same thing that keeps the same side of the moon always facing Earth. Over billions of years, the sun's gravity has slowed down Mercury's rotation, so now its day and year are closely linked. This also means that parts of Mercury's surface are exposed to the sun's heat for long periods of time, while other parts remain in darkness for equally long periods. The extreme temperatures of Mercury. Speaking of heat and cold, let's dive deeper into Mercury's extreme temperature swings. As I mentioned earlier, temperatures on Mercury can soar to a blistering 430 degrees Celsius during the day, making it the hottest planet in our solar system. However, as night falls, the temperature can plummet to a frigid minus 180 degrees Celsius, minus 290 degrees Fahrenheit. That's a staggering temperature difference of over 600 degrees. These extreme fluctuations are primarily due to Mercury's thin atmosphere, which is unable to retain heat. Consequently, the planet experiences brutal daytime temperatures, while the nights are bitterly cold. This dramatic contrast not only shapes the planet's surface features, but also presents unique challenges for potential exploration. Understanding how these temperature swings occur is key to unlocking the mysteries of Mercury and its dynamic environment. These extreme temperature swings occur because Mercury doesn't have a thick atmosphere like Earth does. Our atmosphere acts like a blanket, trapping heat and keeping our planet warm during the night. In contrast, Mercury's atmosphere is incredibly thin. So thin, in fact, that scientists don't even refer to it as an atmosphere. They call it an exosphere. This exosphere is composed of trace amounts of oxygen, sodium, hydrogen, and other elements, but it lacks the density to hold onto heat. As a result, when the sun sets, temperatures drop rapidly, leading to those shocking temperature contrasts. This lack of a substantial atmosphere also means that Mercury is exposed to the full force of solar radiation, contributing to its extreme environmental conditions. Understanding this unique characteristic is crucial to grasping how Mercury functions as a planet in our solar system. An exosphere is the outermost layer of a planet's atmosphere, and it's made up of tiny particles of gas. In Mercury's case, its exosphere contains particles of oxygen, sodium, hydrogen, and helium. These particles are constantly being blown away by the solar wind, so Mercury's exosphere is constantly changing. It doesn't trap heat like Earth's atmosphere does, which is why temperatures on Mercury swing so wildly from day to night. The fascinating surface of Mercury. As we mentioned before, Mercury's surface is pockmarked with craters. But there's so much more to explore. The surface tells a story of violent impacts and geological activity. Each crater has a unique story behind it, often named after famous artists, authors, or historical figures. Impact craters. Mercury has a rich history of impact craters, and the variety is astounding. Some craters, like the aforementioned Caloris Basin, are colossal, while others are tiny. Each impact reveals information about the planet's history. The majority of the craters date back billions of years, providing insights into the early solar system. One notable feature is the hollows, which are irregular depressions found primarily in the young, bright regions on the surface. These hollows are believed to form through a process called sputtering, where high-energy particles from the sun knock off material from the surface, creating these unique features. The lobate scarps. The lobate scarps I mentioned earlier are another intriguing aspect of Mercury's surface. These steep cliffs, which can stretch for hundreds of kilometers and rise several kilometers high, are believed to have formed as the planet cooled and contracted over time. Their presence serves as a striking reminder that Mercury has been geologically active throughout its history, and continues to undergo changes even after billions of years. This geological activity indicates that the planet is not as inert as it may appear, suggesting a complex history marked by processes that have shaped its surface, revealing the dynamic nature of planetary evolution. Volcanic plains. As Messenger revealed, Mercury also boasts vast volcanic plains, remnants of a time when the planet was much more geologically active. These expansive plains formed from ancient volcanic eruptions that spread lava across the surface, creating a landscape marked by the scars of past activity. Studying these volcanic plains is crucial for scientists seeking to understand Mercury's geological evolution and the processes that have shaped it over billions of years. The presence of these features not only offers insights into the planet's past, but also suggests a dynamic history, highlighting the complex interactions between volcanic activity and the planet's overall geological development. Polar regions and ice deposits. The polar regions of Mercury are of particular interest due to the groundbreaking discovery of water ice within their permanently shadowed craters. These craters act as cold traps, maintaining temperatures that remain below freezing, allowing the ice to persist despite the extreme conditions on the rest of the planet. Scientists have hypothesized that water ice was delivered to these regions by comets and possibly asteroids that impacted Mercury over billions of years. This preserved water ice represents a significant reservoir of material that could provide insights into the planet's history and the conditions of the early solar system. Additionally, understanding the dynamics of these polar regions could enhance our knowledge of planetary processes, particularly in how different bodies in the solar system interact with water and ice. The presence of water ice on Mercury highlights the planet's geological complexity and raises intriguing questions about the potential for water in other unexpected locations throughout our solar system. The detection of water ice on Mercury has profound implications for future exploration and potential human colonization of the planet. If humans ever venture to Mercury, these polar ice deposits could serve as a vital resource, providing not only water for drinking, but also oxygen for breathing. This makes the polar regions particularly appealing for future missions, as accessing these ice reserves could significantly reduce the need to transport essential supplies from Earth. Additionally, harnessing local resources would enhance the sustainability of any human presence on Mercury, paving the way for longer-term exploration and study of the planet. Understanding the extent and accessibility of these ice deposits could transform our approach to interplanetary exploration, highlighting the importance of in situ resource utilization in the quest for human expansion beyond Earth. The atmosphere of Mercury. While Mercury's atmosphere is incredibly thin, it's worth exploring the minimal components that make up what little is there. The exosphere consists of trace amounts of hydrogen, helium, oxygen, sodium, calcium, and potassium, creating a unique blend of elements that reflects the planet's harsh environment. This thin atmosphere is so tenuous that it cannot support weather systems or protect the planet from harmful solar radiation, leaving the surface exposed to the full force of the sun's energy. As such, studying Mercury's exosphere provides valuable insights into the planet's formation and evolution, as well as the processes that govern atmospheric dynamics in extreme conditions. The solar wind and exosphere. The solar wind plays a significant role in shaping Mercury's exosphere, creating a dynamic and constantly changing environment. Charged particles emitted from the sun bombard the planet, stripping away atoms and molecules from the surface. This continuous process means that the exosphere is perpetually in flux, with new particles being added while older ones are blown away into space. As a result, Mercury's exosphere is incredibly thin and lacks the substantial atmosphere found on other planets. Studying this interaction between the solar wind and the exosphere helps scientists understand not only Mercury's unique characteristics, but also broader solar system dynamics and the effects of solar activity on planetary bodies. Mercury's magnetic field. As I mentioned earlier, Mercury has a magnetic field, which was a surprise to scientists. But how does it work, and what does it tell us about the planet? Mercury's magnetic field, although only about 1% the strength of Earth's, is intriguing nonetheless. The planet's dynamo effect, generated by the movement of its molten outer core, plays a crucial role in creating this magnetic field. Despite its small size, Mercury's core remains partially molten, which enables the necessary movement of liquid metal to produce a magnetic field. This phenomenon highlights the complexity of planetary interiors, revealing that even smaller planets can possess dynamic processes similar to those found in larger celestial bodies. The study of Mercury's magnetic field provides valuable insights into the nature of planetary formation and evolution. The magnetic field has interesting interactions with the solar wind. It creates a magnetosphere, although it's much smaller than Earth's. This magnetosphere helps shield the planet from some solar radiation, but it's not as effective as Earth's magnetic field. One of the curious features of Mercury's magnetic field is that it is tilted relative to its rotation axis. This intriguing aspect of the planet has captured the attention of scientists who are still working to understand the reasons behind this unusual orientation. Several theories have been proposed suggesting that Mercury's slow rotation, coupled with its proximity to the Sun, might play a significant role in influencing the magnetic field's tilt. Additionally, the interactions between the solar wind and the planet's weak magnetic field could further complicate the situation, making it a fascinating area of research within planetary science. Mercury's unique rotation. As we learned earlier, Mercury's day and year have a peculiar relationship, but there are more fascinating aspects to its rotation. Mercury is in a fascinating 3-to-2 spin orbit resonance, which means it rotates 3 times on its axis for every 2 orbits around the Sun. This unique rotation creates an intriguing scenario where a single day on Mercury lasts longer than an entire year. As it spins, the planet's slow rotation and rapid orbit result in a surprising juxtaposition of timescales, highlighting the complexities of celestial mechanics. This phenomenon serves as a perfect example of how the laws of physics can lead to unexpected outcomes, prompting us to rethink our understanding of time and movement in our solar system. This slow rotation affects how sunlight reaches the surface. The parts of Mercury that face the Sun experience intense heating, while the dark side plunges into extreme cold. This temperature disparity affects the geological processes on the planet. As we continue to explore the universe, Mercury remains a tantalizing target for future missions. Scientists are keen to learn more about its composition, geology, and potential resources. Bey Columbo, the next generation. One exciting upcoming mission is Bey Columbo, a joint project between the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. Set to launch in the near future, Bey Columbo will study Mercury's magnetic field, surface, and exosphere in greater detail than ever before. This groundbreaking mission aims to enhance our understanding of Mercury's geological history and its unique environment. With advanced instruments on board, Bey Columbo will analyze the planet's composition and structure, providing crucial data that could reshape our knowledge of planetary formation. As it embarks on this journey, Bey Columbo holds the promise of unveiling new insights into one of our solar system's most enigmatic worlds. Goals of the Bey Columbo mission. The mission aims to uncover more about Mercury's history, including its formation and evolution. Bey Columbo will also help scientists understand the planet's unique geological features and how they relate to its magnetic field. This knowledge will deepen our understanding of the inner planets of our solar system and their histories. As technology advances, scientists are increasingly optimistic about sending more missions to Mercury. Understanding Mercury's mysteries could provide crucial insights into the formation of the solar system and the conditions necessary for life on other planets. The importance of studying Mercury. While Mercury may be the smallest and least glamorous planet in our solar system, studying it is vital. Each mission and discovery teaches us more about planetary formation and evolution. Moreover, examining extreme environments like Mercury provides clues about potential life in the universe. Implications for astrobiology. The search for life beyond Earth often focuses on planets with conditions similar to our own, such as those in the habitable zone. However, studying extreme environments like Mercury's helps us broaden our understanding of what conditions might support life. The planet's harsh temperatures, intense solar radiation, and lack of atmosphere challenge our preconceived notions of habitability. By examining how life might adapt to survive in such extreme conditions, we open our minds to the possibility that life can thrive in unexpected places. This perspective encourages us to explore areas we haven't even considered, expanding the scope of our search for extraterrestrial life. The influence of Mercury on planetary science. Mercury serves as a unique laboratory for studying planetary processes. Its close proximity to the Sun, combined with its extreme temperatures and lack of atmosphere, offers valuable insights into how planets evolve under diverse conditions. The harsh environment of Mercury provides a stark contrast to Earth, enabling scientists to examine the effects of solar radiation, thermal cycles, and geological activity in real time. By studying Mercury's surface features and internal structure, researchers can refine their models of planetary formation, including the complex interactions between larger celestial bodies and smaller ones, deepening our understanding of the dynamics that shape planetary systems. A reminder of our place in the universe. Finally, exploring Mercury reminds us of our place in the vast universe. This planet, with its unique characteristics and harsh environment, serves as a testament to human curiosity and ingenuity. Each discovery and every mission enriches our understanding of the solar system and the processes that govern planetary evolution. Mercury's enigmatic nature ignites the imagination, inspiring the next generation of scientists, engineers, and explorers to continue pushing the boundaries of knowledge. As we unlock its secrets, we not only learn about Mercury itself, but also gain valuable insights into the fundamental questions about our existence in the cosmos. As we wrap up our journey through the mysteries of Mercury, we've uncovered a planet filled with surprises. From its extreme temperatures and magnetic field to its massive core and fascinating surface, Mercury is much more than just a small, rocky planet. It's a place of extremes, a world that challenges our understanding of what it means to be a planet in our solar system. As we look ahead to future missions and discoveries, one thing is clear: Mercury holds many secrets yet to be unveiled. So keep your eyes on the skies and your curiosity piqued, because there's no telling what fascinating revelations await us as we continue to explore the cosmos. Thanks for joining me on this journey to Mercury. If you enjoyed this exploration, don't forget to like, subscribe, and hit that notification bell so you won't miss any of our upcoming adventures in space. Until next time, keep wondering about the universe around us.